Good morning, first period chemistry class. This is your friendly neighborhood chemistry instructor, Mr. Harper here. Hope you had a nice spring break. I want to visit with you very briefly about what we're dealing with throughout this week, and that is solutions, compounds going into solution, and specifically today, solution concentration. Now, you've been given a text assignment, and I hope you're already digging into it. Specifically, these terms and concepts will be important. Things like, how does a solution form? What does the solubility of a chemical compound mean? The process of solvation, not salvation, solvation. That's a compound, either an ionic compound or a polar covalent compound going into aqueous solution or some other liquid. Crystallization is returning to the crystal or falling out of solution. And then these factors in your text that affect that. For example, solid ionic and solid polar covalent compounds are affected by temperature. As temperature increases, the solubility of most of those compounds also increases. How about the solubility of gases? Gases do dissolve in liquid. If that weren't the case, fish would suffocate. They get oxygen that's dissolved in water, right? But it's kind of, for most gaseous compounds, it's the opposite trend with temperature. As temperature goes up, the solubility of gases in a liquid decreases, okay? So check that out in your textbook. I asked you to take a look at the solubility of gases as related to the pressure above the liquid. And Henry's law applies there, and I hope you're working that problem. We're not going to go over that today. That's on you, okay? But let's talk about this business of solutions and specifically solution concentration. And the key thing to get right now is molarity. Molarity is the way most chemists and most biochemists, most microbiologists, most of the sciences measure the concentration of a solute in an aqueous solution. Molarity, abbreviated by a capital italic M, what is it? Specifically, it's the moles per liter of solution. Okay? And you need to know the molar mass of your compound and to determine the number of moles you have, right? So if I have 1 mole of a compound in 0.5 liters, or half a liter is 1,000 milliliters, don't forget that, you'll need that conversion sometimes. But if I have 1 mole in 0.5 liters, I have myself a 2 molar solution concentration. If I have, let's advance this guy 1. If I have 1 mole of a specific compound in 1 liter, what have I got? Oh, the math is so easy. 1 molar concentration for that solution. Suppose I have 1 mole of compound in 2 liters of solution. Hey, I've got myself a concentration of 0.5 molar, okay? And that is how most chemists would measure solution concentration. The amount of solute dissolved in aqueous or other types of liquid, okay? So, let's take a look at a specific example. Suppose the chemist wants this. Suppose the chemist wants a 2 molar concentration solution of our old simple friend, sodium chloride, a nice simple ionic compound, okay? And let's say, though, he wants a lot of it. Let's say he wants 2 liters of this solution. Okay, well, you know what molarity is. You know it's moles per liter. So let's check this out. First, we need to know the molar mass of sodium chloride. Your handy-dandy periodic table will give that to you, but I'm going to whip it out right here pretty quick. 22.99 grams per mole for sodium, 35.4